Hey folks, welcome to your video on the week 11 in-class exercises that we did not get to do due to a canceled class. So, for what we were going to cover in class, we're looking at break-even, margin of safety, and minimum sales point. When we complete a break-even analysis, we're really trying to find out at which point revenue-wise and for unit-wise, at which point we're basically going to start making money and not lose money. So we're going to start making a profit, not a loss. So that's what we do when we complete a break-even analysis. So let's look at this example. You invested $120,000 in a restaurant and would like to earn an after-tax net income of 20% on your investment. The income tax rate is 30%. Here is a breakdown of costs. So it goes through all the different costs, fixed and variable. The 50-seat restaurant is open 365 days a year, serving breakfast, lunch, and dinner. The average check is $8.25. So how much revenues does this restaurant need to generate in order to break even? So there's a couple things that we need, and I'll just do this a couple times. So one thing that we always need is we need our fixed costs. We're putting together a break-even analysis. And we also need our contribution margin, right? We need a contribution margin percentage and we need our fixed costs. So we need those two numbers. So what's our fixed cost? Well, it's going to be our $3,000 right here, plus our salaries, $41,500, plus $8,400, plus $9,800. And all I'm doing is I'm just adding up all my fixed costs. So in dollars, I have $62,700 in fixed costs. Now to get to my contribution margin percentage, I first need my variable cost percentage. So my contribution margin percentage is 100% minus my variable cost percentage. So let's first add together my 34% for my cost of goods, plus my 28% for my wages, plus my 12%. Okay, and all I'm doing again is I'm adding up my variable expenses. So I have 74% in variable costs. So if I go 100% for my contribution margin percentage, minus the 74% variable costs, I'm left with 26% contribution margin percentage. Perfect. So now we can find out our break-even sales revenue, okay, or BESR. It's in your presentation, as well as there's a handout on Brightspace as to how to calculate that. And the calculation for that is fixed costs divided by contribution margin percentage. Okay. So our fixed costs are our $62,700, and we're going to divide that by our 0.26. Okay, so that's our contribution margin percent. So we need to have $241,154 in sales, okay, in order to break even. So at that point, we will not be losing any money, but we won't be making it anymore. It's important to know this point so that you always understand where you are and whether you're making money or not. Okay? So now, using that information, we can start to look at a few different things. And we can start off by figuring out, based on the current average check, how many covers does that represent in 1 year and per day. So really what we're looking for then is our BEU, okay, which is our break-even units. Okay. Now the calculation for BEU is our break-even sales revenue divided by our average unit price. Okay. If we're talking about hotels, a unit is a room. If we're talking about restaurants, a unit is a cover. So average cover price would probably sound something like average check. So that's what we're looking for. So our break-even sales revenue, we already said it was $241,154. We're going to divide that by our average unit price, which is our average check in a restaurant, so $8.25. That's going to tell me how many break-even units. Break-even units, again, is going to be covers. So how many people based on that average check and based on this break-even sales revenue, I need to serve to break even. So you can't serve half a person, so 29,231 people, and that's going to be for the year. So in the year, I need to serve 29,231 people at this average check in order to get these break-even sales revenue, which will then allow me to start making money any point after that. Okay? And then the question says, and per day, well, per day we could just go 29,231 covers divided by 365. And that's just numbers and the how many days in a year, and then we'll go down to per day. So we need to have 29,231 covers for the year, or if we break it down, 80 per day just to break even at this average check. Okay, so I would be keeping track on a daily basis, and hopefully I've got enough covers and I've got enough of an average check to make sure that I break even every day. If I don't, then I start to be concerned because I know I'm losing money. So wanting to earn, and here, let's do this. Wanting to earn that after-tax income of 20% on your investment, how much revenue do I need to generate in order to get enough IBT operating profit that will ensure an after-tax profit of 20% on my investment? So in order to do this, first of all, if you go to your handout, revenue required for any amount of operating profit is one of the other formulas that pops up in your handout. And that would be fixed costs plus IBT, or operating profit we call that. Okay? And we divide that by contribution margin percent. Okay? Now we have our fixed costs, we've got our contribution margin percent, but the income before tax or operating profit, we don't have that yet, because all we know is that we want to earn an after-tax income of 20% on our investments. So we're going to have to do something that should look familiar to you, and that's from our bottom up. So because we need this IBT, we don't, out of this whole formula, we've got our fixed costs. If you go back, we put together all our fixed costs here. We've got our contribution margin percent. We don't have our income before tax. We haven't calculated that yet. So first, let's start with our income after tax. We want a 20% return on our investment. If I had $120,000 for my investment and I want 20%, I'm just multiplying it by that 20%. So I want to be able to have an income after tax of $24,000. Okay. My taxes, if you remember at the top there, where is it? It's 30%. So if I want to find out my income before tax, we would go our 24,000 divided by, open brackets, 1 minus 0.3. And that's something we would have learned in our bottom-up approach. So I need to have $34,286 in operating profit in order to get this goal. And then if ever you want to, 34,286 times 0.3. I'll turn that into dollars. And if we do the math here, go our income before tax minus our taxes, we should be able to get to our goal. So we're good there. Okay, so now we've got our income before tax, or operating profit. So now we can put together this calculation where we go, our fixed costs, I'll open up a bracket, 62,700. Please make sure that you use BEDMAS, especially if you're using a calculator. You need to first find out what our fixed cost plus our operating profit of $34,286 is. You need to first find that out before you can then divide it by the contribution margin percent. Practice it on your calculator so that if it becomes a question on a test, you're not used to just doing it on Excel. Divided by our 0.26, which is our contribution margin percent. Okay. So, and if I go dollars, sorry, in order to earn my 20% of my investment, I need to have this much revenue. Okay. And this would have been the answer for that one. We'll highlight it so that we can go through it. There you go. Okay. So if I want to earn 20% on my investment, I need this much revenue. It's kind of like saying, it's kind of like using the bottom-up approach. It's exactly the same, actually. The only difference is if you take a look at this formula, and the formula we used for the bottom-up approach was this, 1 minus variable cost percent. Okay. Fixed cost plus operating profit divided by 1 minus variable cost percentage. This is the exact same formula because contribution margin percent, this part right here, is 1 minus variable cost percent. It's the same thing. So if you remember bottom up, you'll feel comfortable with any questions like this or any kind of issues. Now, another break-even formula we use is how to find out profit on any amount of revenue. Okay? So basically, how can you find out what kind of profit, operating profit, you're going to experience based on any forecasted revenue? So the formula for this is revenues times contribution margin percent, close our brackets, and then we're going to take off our fixed costs. Okay? So revenues times our contribution margin percent first minus our fixed costs. That's going to tell us, okay, and that's going to equal our income before tax, our operating profit for any amount of forecasted revenues. Okay? So in this case, we're probably going 400,000, okay, times our contribution margin percent of 0.26 minus our $62,700. Okay, so that's how we would find out our operating profit. So we can go and do it in here. 400,000 times 0.26, close our brackets, minus 62,700. We don't really have to close our brackets, it's just more for it to go through the steps. So then we write equals, so 41,300. So based on our contribution margin percent and our fixed costs, if we want $400,000 in sales, we can we'll probably experience operating profit of $41,300. And all we've done here is we've multiplied our revenues by our contribution margin percent. Contribution margin percent is how much you have left over after you've covered your variable costs. So by multiplying it by that, we've already figured out how much money we'll have left over after we've covered our variable costs. Then we can take away our fixed costs, and that's why we can find out our operating profit. Okay? Now the question says, how much will you earn after tax? It's always important to read our questions. So this is our number before tax. So if we want to figure out our income after tax, we can go our $41,300 minus whatever the tax is. So $41,300 times, and it's 0.3, 30% on tax. Again, all I'm doing is going how much I have in operating profit minus whatever the tax will be. So we can figure out our taxes by going $41,300 times 0.3, which is the taxes, and that should give us an income after tax of $28,910. So that tells us how much we will earn based on these forecasts. Now this question becomes a bit longer, but it's a really great use of break-even, and you should feel comfortable with this as you move forward in your career because it'll be great in making decisions. So a consulting firm has looked at your operation. They offer to help you improve your bottom line by paying them. So let's highlight this $10,000, which is a fixed cost. They guarantee a decrease in cost of goods of 30%. So let's highlight that again. Okay. You know what? Let's highlight cost of goods. And assuming revenues of $400,000, we'll just highlight the key parts here. Is this worth it? What would be the IBT, the operating profit, under the new scenario, and is it better than the one found in question 4? So question 4, we discovered this operating profit based on $400,000 in sales. So now we can start to look at this new scenario. Okay, so our new fixed costs, we need to figure that out. We need to figure out our new variable cost percentage, which will then help us figure out our new contribution margin percentage. So what's our new fixed costs? So paying them $10,000. So our fixed costs before were $62,700. So our new ones are going to be $62,700 plus the new fixed costs. Okay. So it's going to be $72,700 in this scenario. So basically all they're saying is if we pay them $10,000 in fixed costs, okay, pay them $10,000, they're going to guarantee that they're going to reduce our cost of goods, which is this 34%, to 30%. Okay? So we want to figure out whether or not we should actually do this. Does this make sense math-wise based on our $400,000? So what's our new variable cost percent? Well, now we're going to go, instead of 34%, we're going to go 30% plus 28% plus 12. So instead of 30% plus 28% wage cost plus 12%. And if you're not too sure where this 30% is, this consulting firm is suggesting they can decrease my cost of goods to 30% instead of 34% here. Okay? So if I add them all up, 70% is my new variable cost percent. Therefore, my contribution margin percent, which is 100%, minus variable cost percent. So my contribution margin percent in this scenario is 30% now. Okay? So now we can do the same thing we did here, okay, to figure out what my new profit would be. Okay? So let's go look for just our income before tax in this scenario, and it'll help us out. So if we go through that again, so I'll just, we'll go copy and paste. Okay, so we're going to do the same thing in this new scenario. So we're going to call this the new IBT. Okay, and then we'll put the old IBT next to it, and then we're going to do some math to take a look. So our new income before tax, so our $400,000 in revenue has not changed. What has changed is this contribution margin percent of 30%. Okay, and then my fixed costs have changed too in this new scenario, $72,700. And all I'm trying to find out is, with this increase in fixed costs but a reduction in variable cost percentage, am I going to make more or less money? Okay. So if we do that, with this scenario, with this consulting agency, I'm going to have $47,300 in operating profit. My old one, if we take a look, was $28,000. Oh, sorry, that's my income after tax. So my old income before tax, before this consulting agency came along, was $41,300. So right away, with this scenario, I'm making more money. How much? Well, we can find out our absolute and our relative differences. So absolute, we're going to go our new minus our old, so 47,300 minus 41,300. So I'm making $6,000 more in operating profit, which would be $6,000, my absolute difference, divided by my old, so 41,300. We'll put that as a percentage, which represents 14.53% increase just by using this group instead. With this consulting agency, they're going to be able to increase everything by that much. So the answer, I just used break-even math to discover the fact that quickly that, you know what, this does make sense. They can guarantee a decrease, so if it doesn't happen, they would have to compensate us in some way. It's worth it here because I would make $6,000 more in operating profit, even though I'm paying them $10,000 more. Okay. Now, for margin of safety, what this is it kind of shows us how much room we have to play with for our break-even point. Okay, so we're going to use the same example. So if we go to break-even number 1, what was our break-even sales revenue? $241,154. Okay, we'll put that in dollars. Okay. So our margin of safety is going to be the difference between our projected sales and our break-even sales. So in this case, 400,000 minus what our break-even point is in revenue. Okay. So if we take a look at this, this means that we have $158,846. It's kind of a safety net. It's kind of where we can just be a bit safer about everything. And so we know that we've got quite a bit of a margin of safety between our projected sales and our break-even sales. Okay, we would have to drop our sales down quite a bit in order to fall below this break-even point. And that's what we're trying to do. Now what you can do with this information for analysis purposes is divide how much our margin of safety is for the year by 365 days to figure out that every single day we've got a margin of safety of $435. Okay, so that's basically from our projected sales to break even. We've got about that much of a margin. Now for guests, projected sales are $400,000, and if you go back to the previous example, it's an average check of $8.25, I believe. Yeah, $8.25. So that means it's a number. Projected sales, we believe we're going to have this many guests coming through. Okay. Now, our break-even guests, we've already done this math on the other sheet, but $241,154 in break-even revenue divided by the average unit selling price, which is $8.25 again. This should look familiar because we did it on the other sheet. We have to serve 29,231 people at an average check of $8.25 in order to break even. So what's the difference between the two? 48,485 minus the 29,231 covers to break even. So we've got 19,254, a range of safety net of 19,254 covers from what we're projected to do in our break-even point. So this is a pretty big cushion. We need to have 20,000 people less coming into a restaurant to break even and to start losing money. And then if we want to break it down, 19,254 people for the year by 365 days, we would have to have 53 less people every day come in from projections to break-even point to start losing money. Okay, so that's how we would break it down. And that's how you would use your margin of safety. It's really evaluating your projected sales compared to your break-even sales. If this margin of safety starts to get smaller and smaller, so let's say your margin of safety was below 10 people for each day, you would want to be very concerned, because at any point, if you had 10 less people coming in at that set average check, you're going to start to lose money. Okay? This would be a pretty big cushion right here, where 53 difference in covers, 53 less covers per day, that would mean that your projections would be way off compared to what's actually happening. So this would be a big enough margin of safety. Anything below 10, anything below even 15, 20 covers, and sales that are quite closer to the actual break-even amount, you start to be a bit more concerned. Which brings us to minimum sales point. Minimum sales point is a tool that you can use to analyze whether or not you should stay open for an increased amount of time or an extra day, anything like that. Okay? But typically it's for extra hours or extra days is how this is used in our industry. So information you need were sales. You'll need variable costs. You'll need your minimum labor cost and your food cost. Fixed costs stay out of this. We only concentrate on variable costs to find out our minimum sales point. And what our minimum sales point is going to tell us is at what point in sales we need to get to in order to stay open longer, in order for it to make sense. Okay? So our variable costs, we want to find out our variable cost percentage. Okay? Because if you take a look to find out your minimum sales point, we need to divide our minimum labor cost by 1 minus food cost percentage and variable cost percentage combined. So variable cost percentage, it's common size analysis, right? So sales, our variable cost, sorry, divided by our sales, which is always our common number. And that's going to show us that 28.33% is my variable cost percent. My minimum labor cost is going to be how much I'm going to spend in labor. Okay, so if it's costing me $150 per hour in cost per hour for additional staffing, you would do this basically by looking at how much you would need staffing wise per hour to actually staff those extra hours. Okay, and that would be the minimum. So multiply it by 3 for how much it would take over the 3 hours. That's the minimum. Okay, so you have to have this much in labor in order to actually function. And then we need to figure out our food cost percentage, so our $546,000 divided by our sales again. Oh, and that should be a percentage. So 36.4% in food. So now we do some math. So I'll write it out here so that you know how it's going. So we're doing our minimum labor cost, which is $450, divided by 1 minus our food cost, or 36.4%. Okay, we'll write it as 0.364 plus our 0.2833. Okay. And then we close these brackets. Okay, so you need to first add up these two to then take it out of 1, or simply go 1 minus 0.364 minus 28.33. Okay, we basically need to know what's left over after we've taken out our food costs and our variable costs. But let's stick to what this formula says so that we don't confuse ourselves. Okay. But again, make sure you're using bed mass. First add up these two variable costs together, and then go 1 minus whatever the total is, and then go $450 divided by that answer. Okay, so if we rate this out, 450 divided by, open up our brackets, 1 minus, open up a new set of brackets, 0.364 plus 0.2833, and close our brackets twice. Okay, if we do that, so we've discovered that in those 3 hours, if we decide, and this would just be me looking at whether or not I want to stay open in my restaurant for an extra 3 hours. If I do want to do that, I need to experience $1,275.87 in sales for those 3 hours. Now, if I want to, I can go my sales for those 3 hours that I need in order to break even and start making money, divided by 3, and that would give me my sales per hour. So basically, in order for this to make sense, based on the fact that I have $150 in staffing, I have other variable costs of 28.33%, and I have a food cost of 36.4%. When I combine all 3 of these elements, okay, my other variable costs, my labor, and my food costs, these are all variable costs, right? When I combine all of those, it's going to explain to me that I need to make this much money in order to just make this make sense. If I have projected sales for those 3 hours below this number, or per hour below this number, I shouldn't stay open. I shouldn't add any opening hours, or else I'm going to be losing money. Okay? And that's how you use your minimum sales point. So that's our in-class exercises from week 11. I'll still cover these in class quickly. However, this is a great way to go through them before so that we can spend a bit more time starting to move forward with other exercises. If you have any questions, don't hesitate to reach out.